Before I get into the applications here, let me just show you what would happen if you ended up with an augmented matrix of this form as your reduced matrix. Now here, this is as far as you can go with this, because you don't have a 1 here to do any elimination for these two elements here. So basically this says, if you take it out back in equation form, it says x minus 3z equals 13, y plus z equals -6, and then the third row says z equals 0. 0 equals 0. So now that could be rewritten as x equals 3z plus 13. Second equation we can write as y equal minus z minus 6, and then we can just say z is z. And so now we see that x and y both depend upon z. So we could write x as 3z plus 13, y is minus z minus 6, and then z is z. Or again, if you want to use a different letter, that's fine too, but all you're doing is describing the relationship between the three variables. And of course, whatever variable you use as your parameter, it can be any real numbers. Here's a couple of practice problems you can solve. It seems like at one time I had these two backwards, so when you solve them, just check and see if maybe the answers are backwards. Okay, so let's look at some word problems. In this problem, it says, in producing 3 types of brick, we have face bricks, common bricks, and refractory bricks. A factory incurs labor, materials, and utilities costs. To produce 1 pallet of face bricks, the labor, materials, and utility costs are $50, $70, and $20 respectively. For common bricks, the labor, material, and utility costs are $35, $65, and $25. And for refractory bricks, the labor costs and materials and utilities are $75, $85, and $50. In a certain month, the company has allocated $12,000 for labor costs, $17,000 for material costs, and $5,000 for utility costs. It says how many pallets of each type of brick should be produced in order in that month to exactly utilize these allocations. And the exactly portion is important because in linear programming, which is something you might run across if you take a business math class, you actually don't exactly utilize the materials. You might go use less than or equal to the materials. But since it says exactly, we're going to have equations. Okay, so our variables are going to be the number of pallets of each type of brick. So number of pallets of face brick, number of pallets of common brick, and number of pallets of refractory bricks. Now, you want to have 12,000 total in labor costs, 17,000 in materials, and then 5,000 in utilities. So let's look at where those costs are going to come from. Well, if you go up here, you have to kind of search around a little bit. For labor, you have $50 per pallet of vase bricks. And then you have $35 per pallet for common bricks and $75 per pallet for refractory bricks. So your total labor costs are going to be 50x plus 35y plus 75z. And then for materials, you go to the next number, $70 per pallet of face bricks, $65 per pallet of common brick, and then $85 per pallet of refractory bricks. So your material costs are going to be 70x plus 65y plus 85z, and that has to equal 17,000. And then for utilities, it's $20 per pallet, $25 per pallet, and $50 per pallet for the 3 different types of bricks. So 20x plus 25y plus 50z must equal 5,000 available for utilities. And so that's how you set up that system of equations. And I went ahead and put it in an augmented matrix form as well, but as far as setting it up, all we had to do was set up the system. Don't try to solve this because it may not even have a solution that makes any sense. Go ahead and pause the video here and take a look at number 2, and then see if you can follow how I set that one up. It's very similar to number 1, except here our equations are based on the number of radios, which would be 1,500 radios. We have to have 1,250 stereos and 1,900 TVs. Now, in order to do that based on, let's see, based on the number that you can produce, you have 18x for the number of let's see, radios that can be produced from plant 1, 9 radios per hour for plant 2, and 20 radios per hour for plant 3. So 18x plus 9y plus 20z equals 1,500 radios. And then you do the same thing for stereos and the same thing for TVs. Looks like this problem might need to be updated. Stereos, I think, is kind of an outdated product. Okay, let's go ahead and look at this one. I like this one because it's actually going to be a dependent system, but instead of having infinitely many solutions, you'll see that we can narrow the solutions down just using some common sense. Okay, so a trucking firm wants to purchase 11 trucks that will provide 31 tons of shipping capacity. And a Model A truck will hold 2 tons, a Model B truck holds 3 tons, and a Model C truck holds 6 tons. And it says how many trucks of each model should the company purchase to provide the additional shipping capacity. Well, let's let X be the number of Model A trucks, Y the number of Model B trucks, and Z the number of Model C trucks. Well, we only have 2 conditions here. We have to have 11 trucks total, so X plus Y plus Z must be 11, and we have to have 31 tons of additional shipping capacity. And since each Model A truck carries 2 tons, each Model B truck carries 3 tons, and each Model C truck carries 6 tons, then we can say 2x plus 3y plus 6z equals 31. So if we put this in an augmented matrix, it looks like this. Now, in order to get this in reduced row echelon form, I'm going to need to multiply this row by -2. So I'll say -2 times row 1 plus row 2, and I'll put that in row 2. So if you multiply everything here by -2, you'll get -2 across the board, and then of course -2 times 11 is -22. So if I take -2 plus 2, I'll get 0. If I take -2 plus 3, I'll get 1. And then -2 plus 6 gives me 4. And then -22 plus 31 gives me 9. So now I need a 1 here, which I already have. So all I have to do to get rid of the one that's above it is just do minus row 2 and add that to row 1 to give me a new row 1. So minus 0 plus 1 is 1, minus 1 plus 1 is 0, minus 4 plus 1 is -3, and minus 9 plus 11 is 2. Now, so I have a dependent system here, and this says x minus 3z equals 2. But x minus 3z equals 2 can easily be written as x equals 3z plus 2. And this row says y plus 4z equals 9, and that can easily be written as y equals minus 4z plus 9. So the solution set would be, let z equal z, x is 3z plus 2, and y is minus 4z plus 9. But what's going to help us here is we know that trucks have to be whole numbers. So z has to be a whole number. So let's pick some values for z and see what happens. The smallest value z could be the 6-ton trucks. The smallest it could be is 0. Well, let's see what happens to the other variables if z is 0. For x, if z is 0, I get 3 times 0 plus 2 is 2. And for y, I get 0 plus 9 is 9. So 290 would be that would be a solution that works. And then if I let z equal 1, then 3z plus 2 would be 5, minus 4z plus 9 would equal 5. And so x is 5, y is 5, z equal 1 works. And what about if I let z equal 2? Well, 3 times 2 plus 2 is 8, minus 4 times 2 plus 9 is 1. So 8, 1, 2 also works. we run into problems once we hit 3, because once we hit 3, the y value is negative. We end up with negative, and it's not possible to have a negative number of trucks. So any number 3 or greater gives us a negative number of the Model B trucks. So that would not be possible. So we only have 3 options. So we thought we might have infinitely many solutions, and if this was not a word problem, we would have to say that. But since we know that these trucks have to be whole numbers, then and x and y depend on z, we know that these are the only 3 solutions possible. So if you bought any of these combinations, it would satisfy the 2 conditions, where you would have a total of 11 trucks and get your 31 tons of shipping capacity. Now, how you decide which choice to use here, it depends on you. Maybe for some reason you decide you'd rather not have any of the Model C trucks, so you just go ahead and use the first answer. But any of the answers satisfy, any of those 3 answers satisfy the 2 conditions.